So you're probably here because of one of two reasons. Mainly, you saw the thumbnail of this course and you liked it pretty much, so you decided to attend it. And secondly, it just might because you wanted to learn more about software testing. All jokes aside, welcome to Hands-on Software Testing in Python, where we are going to have a deep dive, an in-depth practical guide to unit testing and integration testing via custom-made and real-world case scenarios. So you might be wondering, who in the world is talking to me right now? I am Ahmed Al-Halag, and I will be your instructor for this course. I'm a software engineer, and I've been in the academic field for over 6 years right now. I have a bachelor degree in computer and communication engineering. I'm currently doing my master's in computer engineering, and I've been in the field of doing content for programming and software engineering for over 4 years right now, and I have a bunch of content on my YouTube channel. You can check this out before getting into this course, just so you know what you're getting yourself into. And this is actually the first course of a two-part series that is going to be uploaded shortly to Udemy in a couple of days. The first one here, which is the one that you are attending right now, is the hands-on software testing in Python, where we are going to cover building terminal-based and desktop-based applications and apply unit and integration testing of them. We're going to go through some intermediate to advanced topics like faking and mocking and dealing with boilerplates and file processing. And finally, we're going to apply a very important approach that is called test-driven development, or for short, TDD. The second part of this course that is going to be uploaded in maybe a week from now is going to be the automated software testing in Python, where we are going to focus on web applications, and we're going to see how can we test it via another approach that is called BDD, or behavior-driven development. We're going to use some stuff like tools and stuff like Selenium and Postman and continuous integration. So who is this course for? This course is intended for computer science, computer engineering students in their first, second, up to their third year. If you are a software developer of any level, intern, junior, senior, you will find this course really beneficial to you as well. Recently, I got in touch with one of my acquaintances, and he works in the quality assurance position. He told me that he got assigned in a testing task. He knows how to perform unit and integration tests, but the problem this time was that the existing code base that he received was really big, and he didn't actually know this time how to start. And as an academic, we have a systematic approach for everything. So I shared the notes and tips that I have with him, and I got a feedback from him later on, telling me that using these tips and tricks that I've sent him, he was able to figure out a roadmap that he is actually using for all of his testing tasks. So I thought to myself, why not just grab these notes and tips and grab this systematic approach in analyzing code and designing test cases and implementing them, and build them or put them into use cases and stretch these use cases or case scenarios to make them as realistic as possible, and put it or upload it to this course. So my friends, buckle up because you're in for a big one. So what do you need to know before attending this course? To be honest, a fair background in Python is a must. You need to have a solid background in Python before attending this course. And I'm going to be frank with you, there is no recap for Python control structures or data structures is going to be mentioned in this course. A brief knowledge in object-oriented is actually recommended. Having some knowledge in object-oriented in Python is really going to be beneficial for us. And I've actually written down the exact stuff that you need in object-oriented in Python. You can look it up in any article. We need to know how to create classes, how to create objects of these classes, how to create class variables, how to create class methods, and how to set up getters and setters. This is the only stuff that you need in object-oriented in Python for this course, for the context of this course. And I want you to be rest assured, because this part right there, I don't promise you to cover the entire object-oriented thing in Python, because this is not an object-oriented course, but for the scope of our testing course, for the sake of the examples, I'm going to cover the exact stuff that you need for object-oriented. I'm going to give you an intensive recap. But remember, this is just an intensive recap. It's not going to illustrate everything in deep details from scratch. So again, I recommend that you come with a very good background in Python, and I recommend to know exactly these topics in object-oriented in Python, or at least have some idea on how to create a class, how to create an object, and we can get off from there. Finally, it's going to be a bonus to have a command line interface knowledge. If you do not know anything about the CLI, this is fine, because this section specifically has been introduced in our course, and it has a dedicated lecture. You don't have to worry about the CLI. We're going to learn all about it. The tools needed is obviously having Python installed in your machine, and if you're a Windows user, I recommend installing Git. We're not going to get into version control or source control in this course, but rather Git comes with the Linux oriented terminal. It's called bash, and this is the terminal that we are going to use mainly and solely for testing. We're going to configure how to embed Git into Visual Studio Code, which is going to be our main IDE that is going to be followed in this course. The installation of all these 3 dependencies are going to happen in this course, and it has dedicated lectures for them, so don't worry about them. We're going to go through step-by-step installation guide. As an academic, we love to have references and books to work from, teach from, and learn from. Mainly, I will be using Learning Python Testing book that is done by Daniel Arbuckle here. This is a great book that you can check it out. And at some use cases, as I've told you, I know that the focus of this course is software testing, but at some points we're not only going to use existing code bases to test, but we are going to build our own mini systems. And these use cases where we are going to build the code from scratch that we are going to test later on needs to be built in a very clean way, right? So to follow the best practices in software engineering and principles, we are going to use some of the principles mentioned in this book. Believe me, the Heads First Object-Oriented Analysis and Design is the best book that you can get started with if you want to know more about object-oriented analysis, design, and implementation. So, as you see, this is a small book right there. I just made this smaller to intend that the main focus is obviously unit integration testing. But at some points of the course, we are going to need some principles that are mentioned and examples that are mentioned in this book right there. So these are the 2 books that we are going to work from. So what is the style adopted in this course? As I've mentioned before, we're going to have various case scenarios. Some of them are implemented using procedural programming, implemented in functions, and some of them are first of all designed in a UML class diagram and then implemented using object-oriented programming in Python. If you do not know what is a UML class diagram, that is fine. We're going to discuss all of this in the course. In some cases, we're going to get an existing code base. We're going to analyze it, understand it, and then design the specific test case for this code base, and then implement these design test cases from scratch. In other cases, and it's going to be most of the time this is what's going to happen, we're going to have to build some kind of a mini system ourselves, and then after building the system from scratch, we are going to test and design and test cases for the system that we've built and implement these test cases. And you might ask yourself, why are we writing code to build the system? It's a software testing course, right? So we should only focus on writing unit and integration tests. Why are we wasting time in writing code bases? Well, this is a personal opinion of mine, that if you want to understand something thoroughly, you need to be able to do it yourself. You need to be able to build system from scratch. Like for cybersecurity engineers, in order to be able to find vulnerabilities and in order to be able to penetrate and attack a system, you need to be able to be familiar with that system to begin with. And there is nothing better to get familiar and acquainted with something rather than building it yourself. It's the same thing in testing. For me personally, I believe that in any development journey, in any software developer journey, you need at some point to start to build stuff from scratch before you get to use frameworks, or before you get to test them, or before you get to penetrate or attack them, and check or search for vulnerabilities. And this is the same approach that I'm using in this course. In order to understand systems thoroughly, before testing them, we are going to build them. There's nothing better than building them ourselves first, right? This is the way to understand their ins and outs, and therefore figuring out the test cases for the system that we've built ourselves is going to be a very easy task. It's going to be a breeze. And the main style that is followed in this course is basically a code along, meaning that in the video I'm going to be coding and you are going to be following with me, right? And you are going to be applying everything that I do in your environment, in your workspace. So what are the main objectives? First, we're going to learn how to analyze existing code bases. And you are going to see that at some point, receiving an existing code base as it is and writing test codes for it sometimes is going to be a very difficult task. So you would want to refactor the existing code base, and doing so is going to make your life much easier when you're going to be writing test cases, designing and writing test cases. We're going to perform unit integration tests on procedural codes, functions, and on object-oriented codes, methods, classes. We're going to learn how to perform test-driven development, or TDD for short. We're going to learn how to deal with boilerplate and pass-through methods, or functions. We are going to learn about test coverage. What exactly have we tested? What is left to be tested? And we are going to learn how to run multiple tests simultaneously. We're going to learn something called the BDB, or the Interactive Python Debugger. We will learn how to use the Interactive Python Debugger and how to inspect deep down inside our code while it's running in runtime. We will learn how to create mocks and when to do them exactly based on various case scenarios. If we have real-world data, we will learn how to fake them and sample them. We will know how to deal with file processing and operations, read and write, and we will knock the door on stdin functions and stdout functions. Like, for example, if you have a function that has an input statement or a print statement, how do you get to test that? Finally, we're going to have a sneak peek on the best practices used in object-oriented analysis, object-oriented design, and object-oriented programming by implementing UML design schemes from scratch. And after we implement these design schemes in use cases that we're going to see, we are going to write test codes for these code bases that we have created. So what is going to happen if I get stuck at some point? If you feel lost at some point, not knowing exactly what is happening or how to apply these use cases or information that you are learning about in your project on your own scope, you can always get in touch with me via emails and messages. What happens if I face any errors while applying? You have the Q&A section and you can always post any errors, screenshots that you stumble on, and I will do my best to reply to all of them in a timely manner. What if you want to know more? What if you finished the course and you wanted to know where should you go from there? At the end of the course, if you finish the course, you'll get a certificate, of course, and you can always get in touch or ask in the Q&A section, and I will provide you with a list of recommendations and a precise roadmap to let you know what exactly should be the next step after this. Thank you for stopping by, and I really hope to see you in the lectures.